Welcome to Priority Standard PS 14.2, which is parallelograms, which is including bases and heights of parallelograms. So make sure you are following along and that you've done the warm-up before you start on Activity 1. So you should have done the warm-up as a class. Okay, we have parallelogram A, and we are trying to find the area of these parallelograms. So all we know right now is how to find the area of a rectangle. And we know how to find the area of a rectangle by knowing the base and the height. So if we know the base and the height, which form a right angle, then we can just multiply those. So we're going to do the same idea with these parallelograms. So I see this parallelogram. I know I could cut off right here. If I took a pair of scissors and cut this triangle off of this parallelogram, and then I moved it to the opposite side and connected it, that triangle would fit right here and create a rectangle. Since the triangle is now on the other end, I don't include this triangle that I just moved. So I only want to include it once so I don't overcompensate. So I need to find the base and the height of this new rectangle that I formed. And I'm going to count. So I have 1, 2, 3. This side is 3, and this side is 1, 2, 3, 4, 5. So if I have 3 and times 5, I get 15. And since we don't know the units, we'll just say units squared, 15 units squared. And make sure you are showing your work. B is a challenge, so you could skip this one, or you could try it if you're a champion. So I will come back to that one later. So I'm going to move on to C for now. So I see C kind of has this dotted line right here, which is a line that I could cut off. So this, if I cut it off right here, I have a triangle that I could decompose and rearrange and place on the opposite side of the parallelogram and fill it in here. So now I just have this one big rectangle. Again, I don't include this triangle anymore because I just moved it over to the right side. So now I just need to know the base and the height so I can multiply them. So the base, even though there was a part right here from the triangle, I moved it over here. So it's still 6 units. So the base is 6 units, and the height forms a right angle with the base and is 4 units. So I'm going to do 6 times 4, which would give me 24 units squared. Keep in mind, a lot of people are going to want to use this 4.5. Please do not. That is a diagonal. That does not form a right angle with the base. This is not a right angle, so we don't include 4.5. So that's a trickster one. Okay. So if you tried the parallelogram B, I'm going to kind of show you how to do it real quick. So I would count the base. The base is a side that you can count the units. So I could count 1, 2. So the base is 2. And then I would extend the base. So I'm not actually extending the base, but I'm drawing like a dotted line that would form a right angle with the base. And then I extend it up here. So this line is technically kind of like my height. I'm not forming a new part of the shape, but I'm just trying to say if I extend my base and I form a right angle and go to the opposite side of the shape, how tall is it? So I'm going to count the units. 1, 2, 3, 4, 5, 6. So the base is 2 and the height is 6, so I would multiply 2 times 6, and I would get 12 units squared. There's other ways to get there, but if you got it, awesome. If you didn't, that's okay. That's a really tricky one. Okay. So moving on to what a parallelogram is. So a parallelogram is what we're trying to find the area of right now. A parallelogram is a 4-sided polygon with 2 pairs of parallel sides. So in other words, a parallelogram could be a square because the opposite sides are parallel with each other. And it has 4 sides. A parallelogram could be a rectangle. A parallelogram could be a rhombus. As long as the opposite sides are parallel with each other. So there's a lot of parallelograms, but most of the time our parallelograms are going to look something like this. And a lot of times this will be the base and there'll be a dotted line inside the shape with the right angle, or a dotted line outside the shape with the right angle for the height. So we're going to practice some of that. So one thing with the base and the height of a parallelogram or of a rectangle or square, it needs to be perpendicular. So the base and the height needs to form a perpendicular angle, or make a 90-degree angle, in other words. So we need to make sure the base and height form a 90-degree angle. So we have some examples and non-examples of bases and heights of parallelograms. So look at this on your paper. Some examples of parallelograms. I'm going to draw a line for the base. Draw a line for the base. So notice any side of the parallelogram could be the base. But what we need to know is what the height is. So if the base were extended and a dotted line was going to the opposite side and it formed a right angle, then that could be the height. Here, notice each time it's the base, there's a right angle, and there's a dotted line that forms the height. This dotted line, the base, forms a right angle, a dotted line forms the height. So what I notice is for the examples, all of them have this right angle, or they're perpendicular with the base. The non-examples, notice they do not have a right angle, do not have a right angle, do not have a right angle with the base. This one does have a right angle, but notice the base is here, and the right angle is not anywhere attached to the base. So that's just the opposite side, so that one doesn't work either. So we're going to circle some statements that are correct. So this is on your paper as well. So it says select all the statements that are true about bases and heights in the parallelogram. So A, only a horizontal, this is horizontal, side of a parallelogram can be a base. Notice in the examples, this side is the base and it is not horizontal, so that one does not work because we have an example that proves it wrong. B, any side of a parallelogram can be a base. That is true. Any side could be the base. C, a height can be drawn at any angle to the side chosen as the base. Not any angle. Any angle is wrong. It has to be a 90-degree angle. So cross that guy off. D, a base and its corresponding height must be perpendicular. That's the key. Perpendicular or form a 90-degree angle to each other. So yep, for D. E, a height can only be drawn inside a parallelogram. Notice right here, that's outside of the parallelogram. So the height doesn't actually have to be drawn inside. F, a height can be drawn outside of the parallelogram as long as it is drawn at a 90-degree angle. So here's that example again. Perfect example. It's outside, but does form a 90 degree. So yes, that one works. And then the last one, a base cannot be extended to meet a height. Again, this example right here shows it could be extended to form a height because we have our height right here. So that one does not work. So the only ones that do work are B, D, and F. B, D, F. Okay, our last activity. On your paper, you're going to do this one. You can try this one on your own and then watch the video, or if you get stuck, watch the video as you go. So either way, watch the video, but you can try it on your own first, and that would be great. So parallelogram A is just a rectangle. We know how to find a rectangle's area. We just need to know the base and the height. And notice they form a right angle. All rectangles, base and height will form a right angle just on the outside of the shape. So the base, I'm going to choose the bottom, but you could choose the other side. 1, 2, 3, 4. 4 units for the base for A, and 1, 2, 3, 4, 5, 6. 6 for the height. So I multiply 4 times 6, multiply the base times the height, and I get my area, which is 24 square units, or units squared. Now for B. So B, I'm going to pick the side for the base as a side that I can count the units, not a diagonal. So B, I notice the bottom works for that. So from point to point, this is my line. I can count how long that line is by just counting the squares. 1, 2, 3, 4, 5. So my base is 5. My height needs to form a right angle with it. So I'm going to draw a dotted line inside the shape that goes to the opposite side of the base, and it needs to form a right angle. Now I can count the units. How tall is that dotted line? 1, 2, 3. 3. Now with those numbers, I multiply. I multiply the base and the height. 5 times 3, which is 15 units squared. Again, if you like to cut off that triangle and then move it over so you can kind of see it as a rectangle, that is 5 by 3 units. That works as well. Okay, for C, again for the base, I'm going to choose a side I can count the units. So I'm going to pick the bottom because it's laying flat. So from point to point, how long is that line? So 1, 2. 2 units is my base. Now this one, the height is a little trickier, so I need to extend the base. So I'm going to draw a dotted line there. And then I'm going to draw a dotted line to create a height that is at a right angle with the base. So I count this line that I drew, and it is 1, 2, 3 units for the height. So now I multiply. 2 times 3. And 2 times 3 would be 6 units squared. Remember, area is always squared. Okay, D. D, notice this bottom is at a diagonal, so I'm not going to pick that one for my base because that wouldn't work because I can't count the units at a diagonal. So I'm going to pick this left side. So from point to point, I'm going to draw a line. Notice it is straight. It's right on the grid, so I can count the units. 1, 2, 3, 4. So the base is 4 units. Then I need to draw a dotted line that forms a perpendicular angle with the base. So it forms a right angle. So I'm going to draw a dotted line, and this is going to be my height. If you want to just draw it as a solid line, that works as well. So you can say, okay, this is at a right angle with my base, and now I count the units. 1, 2. So my height is 2. Now with the base and the height, we multiply. 4 times 2 equals 8 units squared. So we found the area of all those 4 parallelograms. Now we need to look at the last one. So this last one says B and H. B meaning any base, H meaning any height. So they're asking, what do we do if we know the base and the height? Notice each time before we just multiplied them. So I'm going to, instead of an X, I'm going to put a dot like that. That means multiplication. So B times H. So I could write the area as B times H, which you could also write in math. You can just write BH. If you write the 2 letters right next to each other, that means you multiply them, BH. So if I put XY, that means X times Y. BH means B base times H height. So you could write it either way. But that is how you would write an expression for that one. Okay, now you are going to try to do the cool down on your own and then ask Mrs. Young to check when you are done. You're going to do parallelogram S and T. You're going to identify a base and a height for each. And then you're going to multiply the base and the height to find the area. And make sure you label it units squared. Thanks for watching the video.